Good morning and welcome to Morning Maths Day 28. You need your pencil and paper. Let's get started. Day 28, question 1 for the year 3 level questions. The value of the 7 in 478. 478. Units, also known as ones, tens and hundreds. So the 7 is worth 7 tens, isn't it? 7 tens. In brackets, 7 times 10 is 70. Or another way of knowing that 7 tens is 70 is you could copy the 7 underneath and put 0 lined up in the units column. 7 tens is worth 70. So there is your answer, 7 tens or 70. Let's move on to question 2. This is plus, column addition. This one's too difficult to do in our heads. Sometimes children sit there for ages trying to do something in their head, when actually writing it down and doing it would just be quicker. This one I think is best to do on paper. So 8 plus 7, let's put our hats on. 8 plus 7 is 15. Pause if you need more copying time. 7 plus 2 is 9, plus 1 is 10. That's not a very good 0. 0 carried a 1, make sure it says 10. 5 plus 3 is 8, plus 1 is 9. 905. Plus makes things bigger, doesn't it? Just checking. 905. And we're on question 3. 344. Take away 251. 344. Take away 251. Make sure you've got the biggest number at the top. 344 is bigger than 251, so yeah, we've got the biggest number at the top. And 4 take away 1, let's do the hats, but 4 take away 1 does work. 4 take away 1 is 3. 4 take away 5 we can't do. If you had 4 sweets, you couldn't give away 5 because you only had 4. So we need to do some borrowing or taking to get this 4 bigger. Borrow from this 3 to make it go down to a 2. It's in the hundreds column, so it's more powerful than the number in the tens column. Borrow the 1, or take the 1. 14 take away 5 is 9. 2 take away 2 is 0. You could write the 0, or you could just leave it empty. 93. We started with 344. We took something away, and we went down to 93. And it's time for question 4. I like these questions. Question 4. This is what I call times tables in disguise. 5 times 30. It's just like 5 times 3, but with a 0 on the end. What is 5 times 3? 5, 10, 15. 5 times 3 is 15. But in the question, the 3 is a 0 on the end, so you can place it on the end of the answer as well. Place it on the end of the answer. So 5 times 3 would be 15, but 5 times 30 is 150. So if you know your times tables, you can also do these times tables in disguise, where 5 times 3, so 5 times 3, that made 15. And then we took this 0 and we placed it there. So 5 times 30 is 150. And now we move on to question 5. We'll do some more of those in the future days. Question 5 is divide. 12 divided by 3. I've got some husky dogs, 12 of them, to put into 3 groups. That's what 12 divided by 3 is. 12 shared between 3. So 3 groups, a group here, a group here, and a group here. 12 shared between 3. Let's share them fairly, like we always do with this. We've been doing this for quite a long while now, haven't we? Always sharing them out fairly. And each group, what on earth has happened here? I've got 1 left over. Do you see what I've done wrong here? Let's count the dogs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The question isn't 13. I had too many dogs. I had too many dogs, didn't I? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's how many I should have. 12 shared between 3. Put the 12 into 3 groups, and each group has 1, 2, 3, 4 in it. So the answer is 4. 12 divided by 3 is 4. The thing that I did wrong was I just counted out too many dogs when I prepared the flip chart. I had 13 instead of 12. So do make sure you've got the right number of things to share out at the start, otherwise it will go wrong like mine did. It's okay if you get things wrong as long as you notice and fix them. That's the whole point in maths. You can notice and fix your mistakes. So we're on the year 4 level section. Question 6. I know a lot of year 3s do carry on past their work into year 4. So we'll do number 6. 4,508. 4,508 plus something equals 4,000. I'm going to write it underneath actually. If I line it up, this might help me to see it. 4,538. Can you see the difference between those two numbers? This one and this one. There's not much difference, is there? Not much difference at all. The units column's the same. The tens column's different. Hundreds column's the same. Thousands column is the same. So the only thing that's actually different is the tens column. There's 3 tens here, which we didn't have in the original number. 3 tens is 30. So 30 is the missing number, isn't it? 30 would go in this box because 4,508 plus 30 is 4,538. And we're on question 7. Plus, is this a big plus or a little plus? The first number's big, the second number's very small. They usually pop a question like this in the year 6 SATs, believe it or not. Quite a big number plus a small number. 4 plus 9 is 13. 2 plus 1 is 3. Just a 3, just a 7. 7,324 plus 9 is 7,333. When I do that in my head, I'm getting the same answer, which makes me happy that it is correct. 7,333. Question 8. Take 134 from 2,987. Which number is the biggest? Because the biggest number goes on the top. This is a strange order to this word problem. Because in the word problem, the biggest number is not at the start, is it? They've got 134 at the start. But we've got to take 134. Take 134. We're taking 134 away from the big number, which needs to go at the top. So this won't work if you put 134 at the top. The biggest number has to go at the top. 7 take away 4 we can't do. We'll take one from here. 17 take away 4. That's 17 take away 4. That is 13, isn't it? 7 take away 3 is 4. Plus the 1 is 5. I've got a feeling I've done something wrong here. Let's see what happens as I keep going. What am I doing here? I'm getting the feeling something's gone wrong. I'm going to be checking this in a minute. 9 times 1 is 8. Sometimes I get this feeling. 2,853. Let's do a little bit of checking in my head. 2,987. I took away 100 would be 2,887. Then I've still got to take away 34. That goes down to a 3. I think that is actually okay. I don't know why I'm getting this weird feeling. I'm going to do it again just to make sure because I want to get it right. I don't want you coming into school or emailing saying, Mr. Saul, you got one wrong, you got one wrong. I don't want you to find one that I got wrong. I want to make sure I get them right. Yeah, I've been doing weird things here. What am I doing? 2, 9, 8, 7, 1, 3, 4. I didn't need to borrow on that first one, did I? Didn't need to borrow. I don't know what I was doing. What on earth was I doing? I've managed to get the right answer, but I've shown you the wrong method the first time, haven't I? I think I was mixing up plus and divide. It actually worked out. I didn't need to borrow, and I borrowed, and then I used I carried one in the answer, and it actually worked out as the correct answer, but I didn't need to do any of the borrowing. So I did get quite confused. Luckily, I think I've got away with it. I'm going to check that one more time in my head. 7 take away 4 is definitely 3. 8 take away 3 is definitely 5. 9 take away 1 is definitely 8 and 2. There wasn't actually any borrowing in it at all, was there? So it wasn't actually that hard. Well, don't know what I was doing there. But I think we're okay. And time for question 9. 2853. I'll remember that one when I look at the answers. 2853. Let's go on to number 9. Double 2,534. Double means times 2. So I'm going to do standard method first. I'll do column method after. 4 times 2 is 8. 3 times 2 is 6. 2 times 5 or 5 times 2 is 10. 2 times 2 is 4 plus 1 is 5. That looks like I've doubled it. 2,534 times 2, 5,068. Let's do a grid method. There's a lot to do in a grid method. I'm not going to be able to fit things into the squares. 2,534. It's a big old grid method, this. Many people like to use the standard method when things get bigger, but not everybody. So 2 times 2 is 4, place of 3 zeros. 2 times 5 is 10, and then there's 2 more zeros to place. 2 times 3 is 6, 1 0 to place. 2 times 4 is 8. So that is a lot of grid method. You have to add up those 4 answers at the end. But I can see that's going to make 5,068. You can see that, can't you? 4,000 plus 1,000, that's 5,000. Nothing in the hundreds column, and then you've got a 68. You can use your place value knowledge to add that, really. 5,068, I've got that twice, so I'm happy with that answer. And on we go to number 10. 469 divided by 7. Or 469 shared between 7. We use the bus stop for these bigger questions which would take too long to share out counters or dots or circles or whatever we wanted. So, how many 7s fit into 4? None, because 7's too big to fit into 4. Carry the 4 if you don't use it. Lots of 7s in 46. I'm going to sing them, but I mustn't go past 46. 7, 14, 21, 28 and 35. 42 and 49, I've gone too far. Start again if you go too far. How many 7s in 46? I mustn't go past 46. 7, 14, 21, 28 and 35. 42. Can't go any further. I've been counting on my fingers, and my fingers say 6. Your fingers tell you what number to put up the top there. You might remember that I sang to 42, but this says 46. So I'm going to count up from 42 to 46. Don't count the 42, but then you go 43, 44, 45, 46. I counted 4 little ones on my fingers. How many 7s in 49? Well, that does work, doesn't it? 7, 14, 21, 28 and 35. 42 and 49. There are 7. So I'm counting this through on my fingers. Get the answer 67. 469 shared between 7 is 67. And we're on number 11, the year 5 level work. This is a different question to what I usually do. How many 10s in 700? Now, I admit I get pretty confused by these sometimes. This is place value, but it's a little bit more advanced. How many 10s is 700? Units, 10s, hundreds. So is 700 no 10s? It has a 0 in the 10s column, but how many 10s is 700? It's not no 10s, because no 10s is nothing. Actually, 700 must be quite a lot of 10s. So what you do is you actually start at the beginning of the number and go along till you've done the 10s column, because that's the one we're looking for, the 10s column, and it's actually 70 10s, isn't it? So the answer is 70 10s, because 70 times 10 is 700. So a weird question, how many 10s is 700? It is 70 10s. These questions will come up a bit more going forward. It's useful place value, because this does come up in questions in tests and things like that. Useful to know that 700 is worth the same as 70 10s. If it was hundreds, it would be 700s. How many units is 700? 700 units. So I'll go through a step at a time. If we say units, it's 700 units. If we say 10s, it's 70 10s. If we say hundreds, it's 700s. So there's actually a lot of different ways of saying that place value. But our answer today, how many 10s is 700, was 70 10s. Possibly a confusing one, but you'll see that plenty more times if you keep doing morning maths. Keep getting your practice each day. And we're on number 12. So 4.85. First of all, we're adding 3 decimals here. They all have 2 decimal places, don't they? That's not very good underlining. 2 decimal places there, 2 decimal places there, 2 decimal places there. What that means is 2 digits after the point. They've all got 2 digits after the point. which means it's going to line up nicely. So I'm going to line up my point going down first. Make sure your point is lined up. 2.35, 4.59. We're going to add all these numbers. Okay, 5 plus 5 is 10, plus 9 is 19. 8 plus 3 is 11, plus 5 is 16, plus 1 is 17. 4 plus 2 is 6, plus 4 is 10, plus 1 is 11. We get 11.79. So 4 and a bit, plus 2 and a bit, plus 4 and a bit, turned out to be 11 and a bit. 4 plus 2 plus 4 is 10. So how do we get to 11? Well, all the bits actually involved a carried 1, so it went up to 11 and a bit. Plus makes things bigger. Last column ends in a 9, so I'm happy enough with that for number 12. And we move on to number 13. 5.67 less than 8. Which number goes at the top? The biggest number. What's bigger? 5.67 or 8? 5 and a bit or 8? 8 is bigger than 5 and a bit. But it has no decimals, 8, so I'm going to give it a decimal point. 8 point nothing is the same as 8, isn't it? So 8 take away 5.67. 8.00 take away 5.67. So we're going to need to do some borrowing this time. 0 take away 7 we can't do, so we go to the 0. There's nothing to take or borrow, so we go right to the 8. Goes down to a 7, and we put 1 over there. Then we can take from the 10, it goes down to a 9, and we put 1 over there. Okay, 10 take away 7 is 3. 9 take away 6 is 3. 7 take away 5 is 2. 2.33. 8 take away 5 and a bit was 2 and a bit. If you know your number bonds, you might know that 67 and 33 adds up to 100. That's why 67 hundredths and 33 hundredths adds up to 100 hundredths, which is why we get a carried 1 and we get 2 for our answer. I think that makes sense. Don't want to confuse you there. There's just a little check with your number bonds at the end. 8 take away 5 and a bit is 2 and a bit. Let's move on to number 14. Question 14, 32 times 45. Long multiplication, but not that difficult because there is lots of little numbers, 2s, 3s, 4s and 5s, and they have quite easy times tables, don't they? So this shouldn't be too difficult, this question. Let's make that a bit neater. Now what I'll often do is place my 0 before I start. And the first thing I'm going to do is 5 times everything. 5 times 2 is 10. Oh, it's in purple, never mind. 5 times 2 is 10. 5 times 3 is 15. Plus 1 is 16. So we said 5 times 32 was 160. I've done the 5. Done that little one. Let's cross them out. The less we have to think about, the better. I've placed a 0 because this 4 is not really worth 4. It's really worth 40. If I placed a 0, the deal is I can pretend it's 4. Makes it much easier. 4 times 2 is 8. 4 times 3 is 12. 2 carried a 1, which is going to be a big one because there's nothing else to do on that line. So I've dealt with the 4. You have to add up your two answers. 0 plus 0 is 0. 6 plus 8 is 14. 1 plus 2 plus 1 is 4. And 1. 1,440 is what I'm getting. I'm just going to check over it in my head. I've got no answers to look at till I get to the last page, so I really don't want to get anything wrong. And you can stop yourself getting things wrong, but you need to check very carefully. And so do I. I don't think you'll ever get to a point where you don't need to check. 1,440 times makes things bigger, doesn't it? And we've got 1,140. Let's go on to question 15. A division. Divided by 4, but a very big number. But actually, I don't think very big numbers are very hard on the bus stop once you get used to it. 58,420, that's what the number is if you say it. We're going to divide that by 4. How many 4s in 5? 1, carried a 1. How many 4s in 18? 4, 8, 12, 16. 4 go into 16. 16, 17, 18. Remainder 2. From 16 up to 18 is 2. So it's remainder 2. How many 4s in 24? 4, 8, 12, 16, 20, 24 is 6. How many 4s in 2 is 0, carried a 2. How many 4s in 20? Will that work? Yes, it will. 4, 8, 12, 16, 20, it's 5. Big answer, isn't it? Probably the biggest division answer I've seen for a while. 14,605. Why is our answer so big? Why is our answer such a big number? I thought division made things smaller. Well, this number did get smaller, 58,000. It's just that it started so big. We shared it between 4, but it is still quite big when we get to the answer. So that does actually make sense. 14,605. And we're on the year 6 work. How many hundreds in 9,000? I like to write this out because I get confused by these. So 9,000 is actually 9,000 units. It would be 900 tens. It would be 90 hundreds. And it would be 9,000s. So if we're looking for the hundreds, it's 90 hundreds. You go up to the hundreds column, 90 hundreds is 9,000. So our answer, it's quite a strange question this, 90 hundreds. 90 hundreds is 9,000. I'm going to check that by doing 90 times 100. You're going to do this with, because I've said 90 hundreds is 9,000, haven't I? I've said my answer is 90. I'm just checking my answer now by seeing what 90 hundreds literally is. Times tables in disguise here. 9 times 1 is 9. Place 3 zeros. 90 hundreds is 9,000. I've got to be honest with you, this answer looks weird to me. 90 hundreds, it doesn't look like it's 9,000 to me, but it is. I find these questions quite confusing, so I check them like that at the end often. 90 hundreds is 9,000, so our answer is 90 hundreds. Let's go on to question 17. A very small number, 7. Well, it's not that small. It's not decimals or fractions, is it? It's still bigger than 1. But 7 is small compared to 98,798. Careful with copying the digits on a big number like this when there's lots of 9s and 8s. 98798. 98798. What are we doing? We're plus 7. In my head, I think it's going to be 98,805. I'm going to check on paper to see if I get the same answer. 98,805. I'm very happy when I've done it in my head and I've done it on paper, or in this case on the computer, and got the same answer. So I'm happy that it's 98,805. And on we go to question 18. If you're one of those people who tries to do everything in your head, I would really advise against that, because you're not taking the chance to get faster at your written workings. Because the more you do written workings, the faster you get at them. So in the end, a lot of the time, they're faster than doing things in your head and more accurate. And if you are good at doing things in your head and you're faster doing them on paper, you can do both. And it's like 2 people doing the test. You've got to double check. Anyway, 1 million, which has 6 zeros, 1, 2, 3, 4, 5, 6. Take away 12. This is a strange question as well. But definitely you want the smallest number on the bottom, don't you? Because biggest number on the top in takeaways. Lots of borrowing or taking in this one, because 0 take away 2 we can't do. All the way to the end, we're going to have to do this all the way along. I know some of you quite like doing this all the way along. It takes ages, doesn't it? Don't make the mistake of crossing out the last 10. That stays as 10. 10 take away 2 is 8. 9 take away 1 is 8. And now it's all very easy, as long as we're careful. 9 hundreds, 9 thousands, 9 ten thousands goes on, 900 thousands goes on. There's nothing left in the millions column. So 999,988. If you added on 12, you'd get back to a million. So I think that's right, 999,988. I'm sure that's right. And we're on to question 19. Long multiplication for year 6. 2, 3, 6, 9 times 45 times 45. If you're one of those people who forgets to place this 0 on the second line, get it done at the start. So 5 times everything first. 5 times 9 is 45. I'll do this bit in purple. 5 times 6 is 30 plus 4, 34. That's a 3. 5 times 3 is 15 plus 3, 18. 5 times 2 is 10 plus 1, 11. Cross out the 5 because I'm finished with that. Cross out the little ones because I'm finished with those. Actually, I might leave them for a bit to do a check in a minute. Then I'll cross them out after. So 40 times all this, or I'll place a 0, so 4 times all this. 4 times 9, 9, 18, 27, 36. 36. 4 times 6 is 24, plus 3 is 27. 4 times 3 is 12, plus 2 is 14. 4 times 2 is 8, plus 1 is 9. Before I add them up, I'm just going to check both lines. It's a big old question. It's easy for me to make a mistake, but I'm going to check both the lines. First, the purple one. 5 times 9, 45. 5 times 6, 30, plus 4, 34. 5 times 3, 15, plus 3, 18. 5 times 2, 10, plus 1, 11. Okay. Then on the second line, 4 times 9, 36. 4 times 6, 24, plus 3, 27. 4 times 3, 12, plus 2, 14. 4 times 2, 8, plus 1, 9. Looks okay. I'll do my adding. Now I can cross out these little ones. Now I've checked. So I don't want to accidentally add those. After all this hard work, you don't want to get it wrong, do you? So 5 is just 5. 4 plus 6 is 10. 8 plus 7 is 15, plus 1 is 16. 4 plus 1 plus 1 is 6. And 1 plus 9 is 10. 106,605. 106,605. Just check my adding one more time. Okay, I think that's correct now. And we move on to question 20. This is a big old division. This is going to take a while. Right. 27,264. I'm not going to write it there actually. I know I'm going to need a lot of space on this page. Trying to plan out my space. I'm not going to be able to use my squares correctly on this one. I just don't have enough squares. This is a big old division. Now, the way that I would advise doing this, there are different methods for long division, there are, but the way that I find most children find the easiest is to create a little 32 times table, because I doubt you know it. I certainly don't know my 32 times table. So because we're divided by 32, we're going to need to know how many 32s fit into different numbers. So first I would create a 32 times table. And you can do that by just plus 32 each time. 32 plus 32 is 64. Then you just plus 32 again. So in the end, I'm going to come out with a 32 times table, which is going to help me do this question. Now what I do first, I've just got into the habit over the years of doing about 5 of them. The most you ever need is 9 numbers in your 32 times table. But I do about 5 of them. I know that 32 times 5 is half of 32 and place a 0, which is 16 place a 0. So I know I've got the 5th one correct. So I'm going to circle now my 32 times table. It's 32. You basically cross out the plus 32s. 64, cross out the plus 32. 96, cross out the plus 32. 128, cross out the plus 32. 160. There's a chance I need more. I've got 1, 2, 3, 4, 5 on my 32 times table. There is a chance I need more, but I'll do it if I need it. I'm not going to do it all at the start in case I don't need it. So now we do this like the bus stop method normally, because we have our 32 times table. How many 32s fit into 2? Definitely none, because 32 is far too big. How many 32s fit into 27? Again, none, because 32 is still too big, so we have to carry the 27. Now I see that my 32 times table is nowhere near big enough, because the first thing I've really got to do is 272. This is a bit annoying when it happens, but you just got to get on with it. This is what long division is about, or something that requires a lot of work. These questions are worth 2 points. Certainly in the SATs in year 6, they're worth 2 points, because they take a long time to do. I've got to add a load more 32s now. I'm going to do another 5. If it gets to this point, I'll just do the second lot of 5. I know I said you only ever need ever need 9 numbers in your 32 times table, but the 10th one is really quite easy, and it actually turns out to be a good check of whether you've got things right. So I actually tend to do 10. 6 plus 2 is 8. 5 plus 3 is 8. This takes a long time. Now I'm on the 10th one, which should be 320, shouldn't it? Because 10 times 32 is 320. And if it turns out to be 320, I will know I've got my 32 times table right. And it does. Good. Halfway was 160. which was 5 lots of 32, 10 lots of 32, 320. This is not easy stuff, okay? This is one of the hardest questions. Most adults don't like division like this. It's one of the hardest questions you'll get really in primary school. These long old division questions, dividing by something like 32. Crossing out all my 32s, I'm circling. It's a bit messy, but I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of my 32 times table. Now finally I'm equipped to solve the question. How many 32s in 272? A lot. 1, 2, 3, 4. I can't go past 272, remember? 1, 2, 3, 4, 5, 6, 7, 8. Any more be too many. So it's 8. There's a remainder to deal with. I've counted up to 256, but I was looking for 272. So my remainder is the difference between 272 and 256. So it's a big remainder. Borrow in or take in. 12 take away 6 is 6. 6 take away 5 is 1 and 0 at the front. 16 is a big remainder. Next we have 166 to search for. Purple dots. I mustn't go past 166. 1, 2, 3, 4, 5. 160, that's not bad. That's 5. That's actually, remainder is not too hard because we got to 160 and that's 166. So remainder is just 6. And then what happens on this last one, especially in the year 6 SATs, if it works, you know you've got it right. 32, 1, 2. It works perfectly with no remainder, you know you've got it right. If you get a remainder, certainly the way the SATs has been the last few years, you've got it wrong because they don't have remainders on these questions in the arithmetic paper. They might in the words papers. Anyway, it worked. I'm pretty confident it worked because I know my times table was right because I had this check here and I had this check here. And then because I didn't get a remainder, I'm happy that 852 will be right. Difficult question, takes a long time, but with practice you'll get faster at it and more accurate, just like with anything in maths. So thanks for listening. Well, we'll have a look at the answers. I especially wrote one down earlier to check. There it is, 2853, so that was right. So check over your answers, pause to keep this page for longer. Thanks for listening. I'll see you again next time.